Hello guys, welcome back to my YouTube channel. So in this section, we're going to be talking about Newton's laws of motion. So in Newton's laws of motion, you have the Newton's first law of motion. We have the first law, which is this here. We have the second law, and we have the third law. So let's talk about the first law. Newton's first law of motion. Newton's first law of motion states that whenever an object is in motion or at rest, it will continue being in its state of rest or motion unless an external force acted upon it. So imagine a car moving. This first law tries to tell us that this car will continue moving. Nothing can stop the car unless something acts upon it, which is friction stops a moving car, unless there's an external force. So which means that in an isolated or closed system, when a body is set in motion, it is being stopped by gravity or the friction in the system. So if there were no external force, a body will keep on being at rest for 100 years, 1000 years to come, and a body will keep on being in motion without stopping. So let's talk about the inertia. So if we talk about the inertia, we're talking about the Newton's first law, which is called the law of inertia. The tendency of a body or object to be in motion or state of rest is called inertia. Inertia explains the reason why a passenger in a fast moving vehicle tend to move forward when a car suddenly stops. So after this lesson, try and enter a motor car, and when the car suddenly stops, you see that you will tend to move forward. Or inertia explain the reason why passenger in a fast moving vehicle tend to move forward when a car suddenly stops. So after this lesson, try just go into a car and observe what will happen when a car will just accelerate or stop. You see you're going to move forward and you're going to move backward. So try this is a practical work. So therefore inertia shows that more massive the greater force required to change its state of rest or motion. This property of mass is called the inertia. Here was trying to explain that the force which we use to push a car is not the same force which we use in lifting a pen or a biro. So the more massive, the greater mass of an object is, the more force is required to put that object in a state of motion or rest. Mass is the quantity of matter it contains, which is measured in kilogram, while weight is the force acting on the body due to the Earth's gravitational pull, which is measured in newtons. Mass doesn't change, but weight change, because the greater or the higher the mass of an object is, the higher potential energy, or the higher weight it become or lesser weight it become. So weight varies, but mass remain the same all over the planet Earth or the universe. So let's talk about momentum and impulse. So what when you talk about momentum, or when you say momentum, what comes into your mind? Momentum of a body is defined as the product of mass and its velocity. The product of mass and its velocity, which is measured in mass times velocity, which is in kilogram meter per second, where the kilogram is in mass, where the kilogram belongs to the mass and the meters per second belongs to the velocity, which means mass is measured in kilogram and velocity is measured in meter per second. So let's talk about change in momentum. Change in momentum is mass times change in velocity. Remember that mass doesn't change. What changes is speed and weight of an object. So where mass remain constant, the velocity change. So velocity changing is what? Final velocity minus initial velocity is the change in velocity. This change in velocity is caused by force, and this force is known as the impulse. So change change in momentum, we can now write change in momentum as what? Change in velocity, or this is the correct formula for change in momentum of a body. Impulse. Impulse is defined as the product of force acting on a body and the particular time it impacts to the body. So impulse is given as force times time. So impulse is equals to change in momentum. Remember that here is the formula of impulse. So impulse, look at the impulse, is equals to what? Change in momentum. Why is impulse equivalent to change in momentum? Because if you're talking about change in momentum, you're talking about the change in velocity, the change in force, the increase or decrease in force. So this force is called the impulse. That is why impulse is equals to change in momentum. That is why during calculation, they may give you impulse and ask you to calculate for the momentum, or they will give you momentum and ask you to find the impulse. But if you're given impulse and asked to find the momentum, which means you're going to write the momentum in kilogram meters per second, and in impulse, we're going to write it in newtons. So let's practice some question. An object of mass 0.04 kilogram changes its speed from 25 meters per second to 29 meters per second due to an external force on the object. Calculate the impulse exerted by the object. First solution. We are asked to calculate the impulse exerted by the object. But before I explain something, let me write out the terms we were given. We are given the mass. The mass is 0.04 kilogram. We were given the final velocity, which is equals to 29 meters per second. We were given the initial velocity, which is equals to 25 meters per second. And we are asked to calculate the impulse. So the formula of impulse is I is equals to Ft, and Ft is equals to change in momentum, and change in momentum is m times final velocity minus initial velocity. So we are asked to calculate the impulse. So to calculate the impulse, we were given the change in momentum, but we are not given the force and time, so we can calculate the impulse. This shows that impulse is the change in momentum. Once we talk about the change in momentum, we're talking about the impulse, the force. So now we're given momentum and we're asked to calculate the impulse. So we're going to use properties or units of momentum, change in momentum, in order to find the impulse. And this is the same thing when you are given impulse. You are going to ask to use the impulse to calculate the change in momentum. So that shouldn't confuse you. So 0.04 kilogram brackets 29 minus 25, which is equals to 0.04 times 29 minus 25 is 4, so which is equals to 0.16 newtons seconds. So we have calculated the impulse. So the impulse is 0.16 newton seconds. So this is the force that acted on the body to make the momentum of the body to change. So let's practice more question. So feel free to pause the video. Just use the relationship to calculate this one. So let's try this one. Solution. A body in motion experiences a force of 0.12 newton for 200 seconds. Calculate the change in momentum of the body. So we are given the force. The force is equals to 0.12 newton, and the time is equals to 200 seconds. In case if this time was given in minutes, you should convert it into seconds. before you solve with it. So we asked to calculate the change in momentum, where change in momentum is m bracket v minus u, which is equals to ft. Change in momentum is equals to what? The impulse. Or you can also write it like this: ft is equals to m bracket v minus u. I hope nothing should confuse you anymore longer. So if change in momentum is equals to impulse and we're asked to calculate the change in momentum, so since we're given the force and time, we're going to just go direct and multiply the force and the time, which is 0.12 times time, which is 200 seconds. This is equals to 24. So what should be the unit? We are asked to calculate the momentum, and remember that momentum is in kilogram meter per seconds and y newton is in newton seconds. So since we are asked to find the momentum, not the impulse, but we use the impulse to find the momentum, so the units will now be in kilogram meters per seconds. So this is all I have for you in Newton's first law. So let's go over to the second law.